Hi, pre-calculus students. This is my final video on graph transformations. I wanted to show you one that had a cosecant just because the graphs are a little bit different. But as far as the transformation is concerned, we want to think about the parent graph. The reciprocal of cosecant is the sine. So we're going to consider the graph y equals 2 times the sine of x minus pi over 2 as our base graph, and then we'll draw the cosecant graph around that. In this particular graph, we have the amplitude being 2, and then we also have a phase shift, and that's going to move the graph to the right by pi over 2. So let's think about our 5 key points for the sine graph. The period is the same. It's going to go from 0 to 2 pi. But then we need to add pi over 2 to each of these values so that we can shift the graph to the right. So we'll have pi over 2 as our starting point. This will be pi, 3 pi over 2. This will be 2 pi, and then this will be 5 pi over 2. So those are our x values. As far as the y values are concerned, when we graph a sine graph, we start at the center, the midline, up to the max, midline, minimum, and then the midline, which is typically 0, 1, 0, negative 1, 0. But we're going to multiply each of those values by 2 for that amplitude change. And so we'll have still zeros at the midline, but 2 and negative 2 for our max and min values. So for my graph, I'm going to start back here. I'm just going to take the tick marks and kind of spread them out a little bit so we can see the asymptotes. I'll have this be pi over 2, and then this will be pi. And then this will be 5 pi over 2. 2 pi is here. Okay. So for my graph, I'm going to start at pi over 2. Right? I've got the point pi over 2 comma 0. And then my max, I'm going to stretch this out. Actually, let's do this here. Have that be 2. And then negative 2 is down here. Okay, so my max will be here, come back to the center, down to a minimum, and then back to the center. So this is my base graph of sine. But I know that the actual graph is going to be around that. Our original graph was cosecant. So I'm going to draw asymptotes wherever the sine graph crosses the x-axis, because that's where sine is equal to 0, so that means that the cosecant would be undefined. So those are my asymptotes. And then my graph is going to sit right at those max and min points for, there'd be another one here, right? For the sine graph, there'd be another one down here. And if I get rid of that green graph, I can see what's left with the blue is actually what the part of the graph would look like. Just a note, if you make a graph of this in Desmos, it'll show you all of the graphs, but it's not going to show you the asymptotes. So that's just something to consider. All right, I think that wraps it up for this particular section, and I'm going to move on to chapter 7.